Hello and welcome to Math 252, Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 3.19 from section 3.4. That's the partial fractions decomposition section. And here they want us to set up the partial fraction decomposition for this integral of x plus 2 in the numerator, and then in the denominator you have x plus 3 cubed times x minus 4 squared. So in this decomposition, we're going to first look at the degree in the numerator versus the degree in the denominator. The degree in the numerator is 1, and that's clearly going to be less than the degree in the denominator, because if we multiplied everything out, we'll have a degree of 5 or something bigger than 1. So that means, yes, we can do this partial fraction decomposition. So let's write out our left-hand side for our decomposition, or the original fraction. That's going to be x plus 2, and then x plus 3 cubed, x minus 4 squared. So in decomposing this fraction, we want to look at the terms that we have, or the factors that we have in the denominator. We have a couple of linear factors that are being raised to the third and second power, so we're looking at linear factors. And whenever we have a repeating linear factor, this has multiplicity of 3, this has multiplicity of 2. Whenever we have repeating factors, what we want to do is we want to account for the repetition of those factors in our decomposition. So our first factor is going to be x plus 3, and so our first fraction will have an x plus 3 in the denominator. And then while that repeats, we need to compensate for another repeating factor for that, and I know it's to the third power, but we have to account for the first, second, and third powers for these things. So we're going to have 3 terms of increasing powers up to the multiplicity that's given. So because the first factor has multiplicity 3, this will have 3 terms. All right. Now, what goes in the numerator? These are all linear. These are all linear terms, so one less degree in the numerator will just be a constant. So we'll have a constant up here and a constant for the second one. Even though it's raised to the second power, it's a linear term that accounts for the multiplicity, so it's still going to be constant in the numerator, and then constant in the numerator for that last one as well. So those are the 3 terms that takes care of this multiplicity 3. And then for the second factor that we have a multiplicity of 2, so we should expect 2 more terms. And the first term here will be x minus 4 in the denominator, and because that repeats of multiplicity 2, we have an x minus 4 in the denominator quantity squared for the second term. So we'll have 2 terms here. And then again, the numerator will just be constants because these are all linear terms. So A, B, C, D, and E would be your numerators for that. So this is the beginning of the partial fraction decomposition. This is the setup. And if you were to continue on, you would be solving for 5 constants, A, B, C, D, and E. And then once you do that, you can integrate. And when you integrate these things, it looks like the term that has an A and the term that has a D would just be an ln. And we have to be careful that the other terms over here are not ln of x minus 3 or x plus 3 and x minus 4. Instead, you'll have to do some sort of u substitution. We'll let u equal x plus 3 and then solve for this somehow. And then you'll have u squared in the bottom, so you're not going to have an ln x anymore. All right. But they just asked us to set it up, and this is how we set it up. All right, I hope that helps. Good luck.